Graph this exponential function 2 times a half to the x. Now the base here is 1/2. 1/2 is in between 0 and 1, which tells you that this guy is going to be exponential decay. It's going to look like that. Now the best way to handle an exponential decay problem is you're going to focus on negatives, right? Negative x values, and then eventually we're going to hit a pattern. And once we hit that pattern, we can be like, you know what, this is just ridiculous. And you start putting some numbers in. So let's pick -3, -2, -1, 0, 1, 2, and then see what happens after that. Okay, now negative exponents are never fun, but that's all right. We're going to do y equals 2 times 1/2 to the -3rd. Whenever you take a fraction to the negative exponent, you flip it and make it positive. So this is actually 2 to the, what's 1/2 flipped? Oh, 2 to the regular third. 2 to the third is 8. 2 times 8 is 16. You become 16. So I have a point, -3, +16. Let's put a dot right there. Next guy, 2 times 1/2 to the -2nd power. 2 times, let's do that flippy again and make it squared. So that becomes 4. 2 times 4 is 8. So the next point we get is -2, +8. 2 times 1/2 to the -1st is the same as 2 times 2 to the +1st, which is 4. Wait a minute. 16, 8, 4. These are just going down by a half every single time, which makes sense because my multiplier here, my base, is a half. So I don't need to do anything more. When I plug in 0, I'm going to get half of 4, which is 2. And when I plug in 1, I'm going to get half of 2, which is 1. And when I plug in 2, I'm going to get half of 1, which is a half, right? And so this just goes down by a half every single time. You're at 2, you're at 1, you're at a half. We'll put you at a quarter. We'll put you close to the x-axis. And you can see how things just kind of level itself out as I showed you there. So now is the part where I ruin everything, and I try to draw this to the best of my ability, which is always very bad. But I'm going to have this curve that's going to level out on the x-axis. I missed them. I'm missing them. That's all right. That's all right. That's all right. I kind of like the picture. I'm very happy with it. Normally I don't draw these well at all, so I'll stick with this. I'm fine with it. But this is exponential decay because you can see my common ratio, my multiplier, is a half. So we're literally taking half every single time. So maybe you start out with a chart and you realize halfway through, I don't need this. And then you just start, using common sense to add a few more points.